So continuing on with examples of the rules for exponents, we're going to do a couple examples using that weird rule number 6 that says anything to the 0 power is a 1. And notice that these next two examples, unfortunately, we read them the same way. So you would typically read this 2x to the 0 power and 2x to the 0 power. So they sound like they're the same, but they're not. And it's that same issue of parentheses that we discussed a minute ago in the last example. So 2x to the 0 power written this way means, remember there's a multiplication there. It's an invisible multiplication dot. And the please excuse my dear Aunt Sally order of operations says I have to do exponents before I do multiplications. So I'm going to have 2 times x to the 0 power, and that x to the 0 power, doing that multiplication gives me a 1, so I wind up then with a 2. Down here, it's parentheses to the 0 power, and anything to the 0 power is a 1. So the parentheses indicate that that exponent is applying to everything in here, whereas up here, the exponent only applies to the x. So one way that I will often say that is exponents only apply to what they're touching. If they're touching the x, then they only apply to the x. If they're touching the parentheses, they apply to the parentheses and everything in it. Okay, and then finally, I want to do a couple of examples to emphasize that warning I gave you that exponents do not understand addition and subtraction. We do not have a rule for 5 plus 1 quantity squared. You have to use your order of operations. So again, please excuse my dear Aunt Sally, you do parentheses, stuff that's in parentheses, before you do exponents. So what's in the parentheses here, there's an operation to do, namely a 6. Okay, and then I do the exponent. 6 squared is 36. And the error I want to point out, hopefully you won't make, please note that this is not the same as, I think I gave you enough room to write this, not the same as if I did 5 squared plus 1 squared. Okay, sometimes people want to put the 2 in on the 2 terms there, and they think of it as distributing, but this is not the distributive property. There's no distributive property for exponents. Maybe that would be a good thing to add to the warning. Maybe that's what I should have said here, that there's, if you go back up, there's no distributive property for exponents. Okay, so the exponent just does not distribute in. And I just, let's go ahead and see that you really do not get the same answer. It's not just that we don't have a rule, it's that it just doesn't work. So 5 squared would be 25, 1 squared would be 1, and you get 26, which is certainly not the same thing as 36. And then one example, same idea, but use it with a subtraction in there. Again, I have to do what's in the parentheses first. 3 minus 2 is 1, and 1 squared, of course, is 1. And this is not the same as what you would get if you did 3 squared minus 2 squared, right? That would be 9 minus 4, which is 5, not the same thing. So this is the correct one for that. And similarly, if you have parentheses squared, this is the correct one. Okay, really common mistake, and I totally understand how people would make that mistake, because we've got a distributive property for multiplication, so it kind of seems like we ought to be able to distribute in exponents too, but unfortunately not. Okay, so we've gone kind of a long time without you having a chance to flex your brain muscles a little bit and see where it is that you need some help and have some questions. So I've got some build your understanding problems for you. And these, I made these to be almost exactly the same as the examples I just did for you. I actually, to tell you the truth, I copied and pasted those examples, and then I just went in and changed the numbers a little bit. So if you need to, you can look at the examples on the previous page and just, see what I did to follow through the steps. But ideally, you can maybe get started on them without looking back at the formulas or the examples I did. But if you need to, that's okay. So I'll leave you with that, and in the next video, we'll come back and I'll go through them with you. See you then.